Hey guys, and welcome back. Today we're going to be talking about constructing a function to model a linear relationship. Now we have had some experience doing this in the past, but this lesson today is going to target more word problems and being able to create a function that represents them. So we're still going about comparing rates of change and their initial values, so we're still on that same learning target, comparing. And we're also going to be interpreting their meanings and context. That's really what we're going to be focusing on today. To be successful in this, we need to identify slope and rate of change, just like we did yesterday, in all those different forms. And we also need to be able to identify the y-intercept, or the initial value, in all of those different forms. So let's take a look at the first example. Okay, so this says at time t equals 0, a bicyclist begins riding at a constant speed. That should tell you something. Let's talk about that first sentence. At time 0, if we are to think about what variables are here, we have t for time, which is going to act like our x, or our input. And then we also have m for miles. Or no, sorry, they say d for distance. So d for distance in miles. And that's going to act like our y value, or our dependent variable. So when they say at time t equals 0, they're saying when x, or when the input, is 0. That should be indicating to you an initial value. Remember, initial value, or y-intercept, is when x is equal to 0, or when the input is equal to 0. So here, since t is being like x, whenever that is 0, it's indicating the initial value. And it says the bicyclist begins riding. So if I were to create a table of values just from what I'm seeing so far, with t and d instead of x and y, I'm seeing at time t equals 0, the bicyclist has gone nowhere. They just begin to ride, so they have not created any distance. That would be the point 0, 0. So let's read the next sentence and see if they give us any other points, or if they give us a rate of change of some sort. It says 10 minutes later. That seems like it's going to be a value we can put in our table. So 10 minutes later, that means time t equals 10. The bicyclist has traveled 2.5 miles. Okay, so they did give us another point in our table that we can use to be able to construct the function. It says write a linear function rule. Remember, linear function rule just means equation. They want us to create an equation, which means you need to think about y equals mx plus b. So let's first calculate the rate of change from the table that we created. So I see my time increased by 10, and my distance increased by 2.5. Rise over run, 2.5 over 10. Again, we don't mix decimals and fractions. So what I'm going to do is I'm going to move my decimal place over one spot, giving me 25. But then we said a while ago, if you do that, you got to add a 0 to the denominator. So from here, I can then reduce. I can divide both of these by 25. And my rate of change becomes 1 over 4. As far as my y-intercept goes, my y-intercept is when x is equal to 0. So my y-intercept is also 0. The equation that we can construct from this is y equals 1/4 x plus 0. You don't even need to include that plus 0 on there. So if you want, you can just leave it. Y equals 1/4 x. That's going to be the function rule that models this situation. Now, I've also provided a graph in case you wanted to plot the points and figure out the equation from there. So we can plot 0, 0. Okay, 0, 0 would be down there. And then we can rise 1 and run 4. I'm just going to leave this. I'm not going to label the graph. And anytime you don't label the graph, I'm going to assume you're counting by ones. So if I rise up 1 and I run 4, the next point will be right there. I'm going to connect the dots. And then that graph is representative of the situation. If I want to put a couple labels on here, I have time down on the bottom. I have distance on my y-axis. All right, let's have you guys give this a try on your U-Try. Alright, so in the past, especially in yesterday's lesson, I was showing you guys how to compare rates of change in slope. Well, this is another way that we can create a function rule, but just from 2 points. So there is a little bit of a procedure here. So please make sure if you're confused on anything I'm about to write, raise your hand, ask a question, make sure you understand what's going on. So we're still going to be creating equations in the form y equals mx plus b. And we even practiced this the other day, taking 2 points and finding the slope. So recall that the slope formula is y2 minus y1 over x2 minus x1. So let's say that this is the first point and the second point. That makes this the first x and the first y. And this is the second x and the second y. So the first thing I'm doing really here is calculating the rate of change. I'm calculating my slope, my m, to be able to plug in y equals mx plus b. So I'm seeing 12 minus negative 2 over 3 minus negative 4. Remember, whenever we minus a negative, that's really turned into plus a positive on both the top and bottom here, which gives me 14 over 7. 14 divided by 7 is 2. So far, I have y equals 2x plus b. I still need to figure out what that b value is. In order to do that, take either of the 2 points. It does not matter which one. I'm just going to take the first one I see. Actually, I'm not. I'm going to take the second one only because then I don't have to deal with those 2 negative numbers. So I'm going to take that point and I'm going to plug it into the equation that I've sort of completed so far. And I'm going to plug into the variables, x and y, because that's what those coordinates stand for. So here, the y is 12. So instead of y, I'm going to write 12. And I still have the equals and the 2. But then instead of x, I'm going to replace that with the x in the point, which was 3. And we still have the plus b. We're trying to figure out what that plus b is. But now that we've replaced both x and y, we can simplify and solve for b. So I have 12 is equal to 6 plus b. And if I were to subtract 6 from both sides, then I get my b all by itself. It's isolated. And I have that b is equal to 6. So now I can just take what I know b equaling and kind of morph the equation that I already had into its completed form, which is y equals 2x plus 6. That is how we're going to be able to create our function rule when you don't have a graph. You don't have a table, you just have a set of 2 points. And now I can graph this line just by using my equation. I see my initial value, my y-intercept is 6. So I'm going to plot that first. You always want to plot your initial value or your y-intercept first. 2, 3, 4, 5, 6. And then from there, apply your slope. So here my slope is 2. Or if you're ever unsure of how to get to the next point, change your slope into a fraction. So really this is 2 over 1. So I need to make sure I rise 2 and run 1 before I plot anything. Okay, so on my graph, I go up 2 over 1. That would be that point right there. So now I just need to connect the dots, and I've formed the line of my function. There we go. So we got our function rule right here, and then its corresponding graph. That's the main idea, and it's going to take a little bit of practice in order to be able to create the function rule from 2 points. So let's have you guys give this a try. We're going to go through an example first, and it's going to be in a context, but that's really what we're going to be doing. We're going to be looking for what are the 2 points that they're giving me in this context, and then I'm going to have to create my y equals mx plus b in the way that we did in the key concept slide. So it says in this example, a jewelry store sells charm bracelets and charms. A bracelet with 2 charms costs $7.50. A bracelet with 4 charms costs $9.50. So I'm going to create a table. I have x and y. Well, what's changing? My x would represent the charms, how many charms I'm buying, that's what's changing. And then y would be how much they cost. So I have a bracelet with 2 charms is going to be $7.50, and a bracelet with 4 charms is going to be $9.50. So that's 2 points. I just set it up in a table instead of writing it as a coordinate pair. So I'm seeing my x's are changing by adding 2. My y's are changing by adding 2. Rise over run gives me that my slope is 1. So far I have y is equal to 1x plus b. Again, take either of the 2 points. I'm just going to take the first one I see and plug it in for x and y. So I've got my y is $7.50. My x is 2. I need to simplify now. I have $7.50 is equal to 2 plus b. And then I should subtract 2 from both sides to get b all by itself. So I'm seeing my y-intercept is 5.50. So my function rule, I'm going to go back to my halfway done function rule here. It becomes y equals, and you don't have to write the 1 if you want to just write x, y equals x plus 5.50. There's our function rule. It does not say, sorry about that. It doesn't say that you have to graph it, but I do want to show you what the graph of this would look like. Okay, so I see a y-intercept of 5.50. I'm going to say that this graph is going to be scaled by 1s. If you want to label it, you can. I don't think it's completely necessary, but I know some of you guys really like labeling your graphs, so I'm going to label it for you guys. Just scaling by 1s. Okay, and I see my y-intercept is supposed to be at 5.50. So that's halfway between, make my point a little bit smaller. Okay, so halfway between 5 and 6. And then we have a slope of 1. So I want to rise 1, which would get me up to, and I'm going to zoom in here. You can rise 1 even if you're in between points. So I'm going to show you guys, I'm going to rise 1, which means from 5.50 I have to go up to 6.50. And then I have to run 1. So my point will end up being, again, kind of halfway between 2 numbers here, which is right there. Okay, so now connect your dots. There is the graph of the line. And we don't want this to extend in any other quadrants because it doesn't really make sense to have a negative charm or negative money. So let's have you guys give this a try in your U-Try. right, so I've got one last example for you guys here. It says a gardener collected 40 gallons of rainwater in a tank. Later, the bottom of the tank cracks and the water starts to leak out. The water leaks at a constant rate of 2 cups per minute. Write a function rule to model the amount of water in the tank at a given time. I think problems like this are a little bit easier just because they actually tell you what the initial value and the rate of change are in the actual context itself. So it says he collected 40 gallons of rainwater. That's what he started with. That's what he collected. So if I can read about what something starts at, I should be able to identify that as the initial value. Okay, so I'm just going to make a note of that this is the initial value, or the y-intercept. And then I should also be able to identify the slope from the context of the words. It says constant rate. That's indicating a rate of change or a slope. 2 cups per minute. So far, just in this context alone, I have an initial value, a B of 40, and an M, just from that word per, an M of 2 cups per minute. So that would give me a function rule of y equals 2x plus 40. Okay, so a little bit easier. We didn't have 2 points. It was actually written in words. We just needed to be able to interpret it correctly. So let's have you guys give this a shot in your U-Try. All right, so to recap, we were able to compare rates of change in initial value and interpret their meanings in context, especially in context. Meanings in context was what we did today and yesterday. We also were able to compare them fully at the end of the lesson yesterday and today. And we were successful by first being able to identify the rate of change from either a graph table or context and identify the y-intercept or initial value from a graph table or context. So once you're ready, go ahead and start your practice.